Now we will talk about something of the VRRP. As we know, if the terminal want to visit the internet, we need some parameters like the IP address, like the mask, and the gateway. And what's the function of the gateway? If the terminal want to forward the message to different segment, we will send the message to the gateway to help us to forward out. So the gateway is very important. And in the real network, if we use the layer 3 switch or the router to become the gateway and the devices is broken, that means all the segment terminals cannot visit the internet. So we hope that about the gateway, we also can provide some redundancy function. If the first devices is broken, we also can have the plan B, the other devices to help us for the traffic out. So in this scenario, we will deploy the protocol of VRRP in our network. And what's the function, what's the principle, and what's the key configuration mind. If you are interested, please follow me to see the detailed video.
Hello guys, this video we will talk something about the VRRP. The same process. Before we talk about the detail, let's have a review of the DHCP practice question. The terminal obtains an IP address through DHCP, and the server finally determines in which message is the information such as the IP address and mask provided to the terminal include. The answer should be D. As we know, the client first step will send out the discover message to ask who can give us the IP address, right? And then the server will give you the offer message. I can give you the IP address. Please try to use like 101.1.1/24, something like this. And then client will give a request. And can I use this IP address? Because in this process, maybe we have multiple servers in our network. And finally, if the server gets a request message from the client, I will give you the acknowledgement. Sure, you can use this IP address, and then to remember the IP address from the pool to record it, that this IP address cannot be used by the other people. So finally, we can determine by the ACK message. Of course, in the offer message, we also can provide some IP address information. So the answer should be D. In this video, we will talk something about the VRRP, right? And why we need the VRRP. Usually, all hosts in the same network segment are configured with the same gateway to access the external network, right? For example, like this topology, we have PC1 and PC2. If they want to visit different IP segment like the external network, then we will ask our gateway to help us. Please help me to forward the message to the other segment, something like this. So the gateway is very important in our network. But if the topology like this one, and only one gateway device, and if the device is broken, all the hosts cannot be visited to the other segment, like this device is broken. Now, if we want to send the message to the external network and we send the ARP request to our gateway, please help me and tell me what's your MAC address, and no one give you the reply. And how to meet the requirement, maybe when the administrator is working and to do the troubleshooting, and finally to find your gateway is broken. And before we provide the correct devices, all the terminals cannot visit the external network. So we hope we can have the technology. If the main devices is broken, we still can have some backup devices. And how to change to select the backup? We can automatically select it, not by people manually to choose. So that's why we need the protocol of the VRRP. And then let's see the VRIP. If here the topology, we have two terminals to connect with the access device, and we can provide switch A and switch B to help to visit the external network. And someone maybe say, we can give two IP addresses of switch A and switch B because by default, the physical device cannot have the same IP address, otherwise there is a conflict. In this scenario, maybe normally the terminal use switch A IP address as a gateway. If switch A is broken, we can change the gateway address of switch B. But you will find the work is very busy, right? And if you have lots of terminals, maybe the user don't know what's the meaning of the gateway. So we can deploy the VRIP protocol, and if we use this protocol, we can select a virtual router to become a gateway of the terminals. The VRIP protocol is virtual router redundancy protocol. So we can make multiple devices to become a backup group for router or maybe for layer 3 switch. Then we will select a virtual router. And the virtual router will work as long as there is still a router working in the backup group. That means if we use this protocol, we will select a virtual router and give the IP address. And the terminal will use this virtual IP address to become a gateway. But finally, the message still needs the physical device to help us to forward the message out. So in this virtual group, in this backup group, we have to select one device to help us forward the message out. If this device is broken, we can select another device to become the physical device to forward the message out. So this is a basic function. If now we create the VIP group, add switch A and switch B in the group, and finally create the virtual gateway to become the gateway address of the terminals. And normally the message will select switch A to become the master device and help us to forward the message out to the external network. If the switch A is broken, the terminal maybe don't know this information, right? I will select switch B to become a physical device to visit the destination. But in the whole process, the terminal don't know that now we already switch A to become switch B to become a new gateway. And I only send out the message to our gateway, and they will think my virtual gateway help us forward the message out. And in this process, how to find the switch A is broken, how to change the master device to become switch B, and then how to force the message out. All the process will be done automatically. And we only need to add the configuration to create the VIP group, to add switch A and switch B in the group. That's all. So it's very easy for us if we use a VIP protocol. And how to select the VIP who is master, right? Because we only need one device to help us forward the message out is enough. So in this VIP protocol, we also have lots of concepts we have to know. First, like this topology, we have switch A and switch B, and also create the SVI interface to give the IP address for VLAN 10. And we have 3 terminals belong to the VLAN 10, and give the IP address of terminal and also give the gateway address. And you will find the IP address of switch A and switch B, the IP address is different with the gateway. So in this scenario, first, we have to add the switch A and switch B in the same VIP group, right? And we will use a VRID to indicate the group. For example, VRID now is 1, and later we will change the priority. Because now in the group we have two devices, switch A and switch B. We have to select one device as a master to help us forward this message out. And we also have some principles. For example, first to compare the priority. Higher value is better. Now maybe you can use command to change the priority of switch A to become 110. The default value is 100. This is the function of the priority. Of course, by default, if you don't change the priority, switch A and switch B, the value will be same. And then you can compare the IP address because IP address will be unique. Also, higher IP address value will be better. This is a priority. And then we have to configure the virtual IP on switch A and switch B. This virtual IP address will be the gateway address of the terminal. And pay attention about this one. The virtual IP address can be same, also can be different with the physical interface. In this topology, the virtual IP address is different with the physical interface, right? So if you configure the same virtual IP address with a physical IP address, for example, now you use the virtual IP address 192.168.10.252. Switch A will direct it to become the master. This one we call IP address owner. And now, if we already use a command to create the VIP, that means now we create the VIP group 1 and give the virtual IP address 192.168.10.254. And later, when we use a DHCP or maybe static way to assign IP address for the terminals, the gateway address should be the virtual address. And later, according to the parameters, switch A will become the group 1 master. Switch B will become the backup. So finally, the master router in the VIP backup group 1, the priority is 110, the virtual IP address is 192.168.10.254, and by default, the VIP in preemption mode. What's mean preemption mode? First time how to select the master, we can compare the priority, right? If later we reduce the priority according to some special scenario to make switch A priority to become 90, the value will be smaller than switch B. If we enable the preemption mode, that means in the VIP group, we only select the master who has highest priority. So switch B will become new master. If we disable this mode, that means if switch A cannot work, then switch B will become a new master. Although maybe now we found the switch A priority is 90, but still switch A still can send out the VIP message to everyone that I can work now. So this is a function. The preemption mode is enable or disable, the different result. If we enable the preemption mode in the VIP group, only the highest priority will become the master. Otherwise, if the master selected successfully, the backup only have to wait, which the master cannot work. Then I will be a new master. So this is the mode of the preemption. Then let's see the VIP back group. So how to select the master backup and how to create the VIP group. We have lots of concepts, right? And now we can see one by one. The VIP backup group, that means we create the group for routers or maybe the same for layer 3 switches. And all of them will run the VIP protocol. And if they belong to the same VIP group, we call they belong to the backup group, and is functional equivalent to a virtual router. And each virtual router will have an ID to distinguish with each other VIP group, backup group. And the backup group is interface based, and the interface in the backup group must belong to the same broadcast domain. So pay attention about this one. Because I have to send out the VIP message to you, and I also will receive the VIP message from the other devices, and then we will compare the priority, compare the IP address to select the master, right? And this message of the VIP packets belong to the multicast message. So if they belong to the same broadcast domain, I can send the message to you successfully. So pay attention about this one. And the next one is a VRID. The range is from 1 to 255. And this VRID we have to create manually. And the user configurable to distinguish between different backup group. If we want to add them into the same group, they must have same VRID. So this is the principle you have to know it. Give the same VRID. And the next one is about the virtual IP address and the virtual MAC address. We will use the IP address and the virtual MAC address for the virtual router. And the virtual IP address will become the default gateway of the terminals. And also we have to provide the MAC address, right? Do you still remember the process if the terminal want to visit the different destination? The first step, we have to send out the ARP request message to ask, please tell me my gateway, show me your MAC address, right? And then your gateway receives this message. I will give the reply, what's my MAC address, something like this. Then the terminal will do the encapsulation successfully. The virtual IP address is very easy to understand, will become the gateway. And how about the virtual MAC address? By default, if we create the VRIP, we will use the virtual MAC address. This MAC address is special because the first bits are same, 00005E, 0001, and gives a virtual ID. If the virtual ID group is 1, so the MAC address last 2 bytes will become 01. Instead, the real MAC address of the interface. So, if you use the virtual MAC address, although maybe switch A is a master, I will apply the virtual MAC address to all terminals, right? If the switch A is broken, switch B to become a new master. Because we have the same VRID, so when I apply the virtual MAC address, this one is same like the switch A send out. So all the terminal will find I still use the same gateway. But if you change the mode to become real MAC address, the MAC address of switch A and switch B is different. So the terminals have to refresh the ARP table if the master and backup is changed. So this is a function, and you have to know the special virtual MAC address. If you use a tool like the Wireshark to get the ARP message or get some special message from the terminal or from gateway, the MAC address is special. The first 24 bits are fixed. So this is a virtual IP and a virtual MAC address. The next one is a master router and a backup router. The master router is a router that finally will be for the message for the terminals. And the backup one will be in the listening status. I'm waiting and listening the message from the master. If the master cannot send out the message, I will immediately to become a new master. So this is a function of the master router and the backup router. Once the master router fails, the backup router will take over and works. So this is the relationship between the master and the backup. In the group, we only can have one master. lots of backup routers. The next one is the priority. If in the group we have multiple devices, how to select the master, how to select the backup? The first parameter, we will compare the priority. Higher priority device will become the master. And by the default, the value is 100. And the range is from 0 to 255. You can use the command to change the priority. For example, you think switch B maybe has higher performance. We hope switch B can be master. You can use the command to change the priority. If the priority is same, we will compare the IP address. Higher IP address will become the master. So this is the principle. And the default value is 100. But pay attention, you only can use the command to change the priority value from 1 to 254 because the 0 means maybe you delete the configuration of VRRP immediately to make the priority to become 0. And 255, we have special meaning belong to the IP address owner. So if you want to use the command to change the priority, the range is from 1 to 254. So this is the priority value. And the IP address owner will immediately to become a master. We will skip the comparison of the priority and the IP address. And the next one is a preemption mode. And we also explain what the function is of preemption mode, right? If the preemption mode is turned off, the higher priority backup router will not active become the master router, even if the master router has lower priority, right? If the master is broken, then the backup will become a new master. So you can make your network more stable. And the preemption mode is mainly applied to ensure that in your network, higher priority router will become the master all the time. In this requirement, you can enable the preemption mode. And by default, we already enable this preemption function. And then let's see the process, how to select the master, how to select the backup. The first one, to physical router or layer 3 switch, we have to add the command of the VRP protocol, right? And then they will send out the VRP message belong to the hello message. And in this message will carry the priority, the IP address, and the preemption mode is on or not. All the information will be added into the packets. And then we will send out the message and also will receive the message from my neighbor. Then we will find, first we have to do some negotiation. For example, our VR ID is same or not. Our virtual router IP address is same or not. Something like this. And then we will compare the priority and the IP address to select who will be the master, who will be the backup. In this topology, if we don't change the priority, we can directly compare the IP address. And the right IP address is bigger than the left. So the right one will become the master. And also, pay attention, the right one becomes the master means all the terminal send out the message will be forwarded through the right router. But the terminal still will use the virtual IP address as a gateway address. So if the master is broken, then we will select the left router to become a master, and the master will help us to force the message out. So in this process, how to detect the master is working or not, how to switch, this action will be done automatically. And then let's see the VRIP packets. how to select the message and how to detect, because all the devices will send out the VRP message. And this message belongs to the multicast message. That's why we say two interfaces within the same VRP group must belong to the same broadcast domain. And the VRP message only will be sent by the master router in the regular interval times to send the message out. And we also will use this message to detect the message. First, we have to select the rule, right? Who is a master, who is a backup. And also, we will use this message to detect the master is working or not. And this VRP protocol will be encapsulated into the IP packets, and the protocol number is 112. Multicast message means about this VRP in the IP header, the destination IP address is a multicast address. And the address is 224.0.0.18. So maybe you use the tool like the Wireshark to get some packet, and you find the destination IP address is this IP address. That means this belongs to the VRP message. And passing the same broadcast domain, we will use the multicast message to find each other and to do the negotiation. And about the VRP status, we already know the master and the backup, right? And then we also have the third status for the initialize. If the router enters this status, maybe the first time we add the configuration of the router, and then you directly use a command to check the status, you will find the status will become initialized. And then they will send out the message to do the negotiation. Master is finally the device can forward the message by the terminals. And the backup will be on the listening status, waiting the VIP message from the master. And if we detect that the master cannot work, we will directly to change. So this is the function of three status. At the beginning of them, the status is initialized. Then, if we detect the configuration, my virtual IP address is same with my physical address, then I will find this device will become the master because this device is IP address owner. Otherwise, this state will become backup. And if we receive shutdown message, we will come back to the state of the initialize, right? Maybe you shut down the physical interface. And between the master and the backup, we also can change the status. For example, if the master receives higher priority VIP packets and the preemption mode is on, is enabled, then I will directly change the status to become backup because I will let the higher priority router to forward the message. If the backup router within the specific time period and we don't receive any VIP message from the master, I will think that the master is broken now. I will become a new master. So this is three status will be changing in different way in different scenario. And about the next one is a VIP interface checking. And what's the function of this one? Like this topology, the master has higher priority with 150 and the backup priority is 100. So according to the priority, finally the left router will become the master, the right one will become the backup. And which scenario the backup will become a new master? If the master is broken, right? We will select the backup one to become new master and forward the message out. But in some special scenario, for example, some broken of the uplink line cannot work. Now the uplink, for example, maybe cannot connect with the up routers. In this scenario, the master router is still working, right? We still can provide the power function and we can have the normal routing table, something like this. But that means all the terminals still will forward the message to the left router, and finally the left router maybe will discuss the message, maybe will forward the message to the backup one to help us to forward the message out. This is not the best path. So in this scenario, we hope that the master can directly to let the backup router know you should be a new master, because now if I want to force a message out, I don't have the correct route. So in this scenario, you can add the check monitor. For example, if this link is broken, I can directly to reduce the priority. For example, to reduce left priority to become 90. The priority value is lower than 100. So the right one will become a new master router and then forward the message out. So this is a function of the check. And how to meet the requirement, how to detect the uplink, and how to decrease the priority, you have to add the configuration of the routers, and then router will do the detect. So that's all about the basic principle of the VRRP. And the next video we will talk the basic configuration of this protocol.